turn to page 309 in your textbook. Here we have example 2. When his Sunday school class went canoeing, Brent paddled 12 miles down the river in 3 hours. After paddling back upstream for 2 hours, he had traveled 4 miles. How fast does Brent paddle in still water? And what is the rate of the current? So, first we want to find Brent's paddling rate and then the rate of the current, B and C. So we are given information for downstream and then for upstream. When we're going downstream, we add Brent's rate with the current. But when we go upstream, then we're subtracting Brent's rate of speed and the current. We know the time that he took to go downstream was 3 hours. The time for him to go upstream, though, was 2 hours. And then the distance he traveled from or downstream was 12 miles. And the distance he went upstream was 4 miles. Now, we know distance is equal to the rate times the time. So, our time times the rate, which is B plus C, is equal to 12. Then for the upstream, 2 hours times B minus C is equal to 4 miles. And in order to eliminate or have your variables by themselves, you have to move this 3 over to the other side. You divide. Then here also you divide by 2. You're going to end up with B plus C equals, what's 12 divided by 3 is 4. And then 4 divided by 2, we have B minus C equals 2. If you follow the textbook, the example here, after we have simplified these two equations, both equations can be simplified and then eliminate the C terms because you have C and a negative C, right? You can eliminate those by adding what you have left. So B plus B is going to give me 2B. This was 4, okay, so 4 plus 2 is going to be 6. So 2B equals 6, and then your B is going to be 3. And if I plug B back in, or the 3 back in, I can calculate that my C will be 1. Brent's paddling rate is 3 miles per hour, and the rate of the current is 1 mile per hour. All right, a knot is a unit of speed referring to nautical miles per hour. That is approximately 1.151 miles per hour. We're going to start taking a look at some examples now with knots. It is often used to measure the speeds in aviation and sea navigation. Turn to page 310 in your textbook. We're going to take a look at example 3 here. When flying the 1,900 nautical miles to California, James flew non-stop for 4 hours. Flying home by the same route and under the same weather conditions, the flight took 3 hours and 30 minutes. What rate would the airplane have flown with no wind? And what was the wind speed? So, take a look at your questions, and we have to define what are the two things that we're trying to find now. Okay, we've got a flight to California and then a flight to home. We have to define, first of all, the rate of the airplane with no wind is going to be P. then the wind speed is going to be W. Which flight took longer? The flight going to California took longer going. That was so that was why we have the rate of the airplane minus the rate of the wind. But then, coming home, the flight was only 3 hours and 30 minutes. So here the rate was faster. The rate of the airplane with no wind, you add that to the rate of the wind speed. Our time, we know that to California took 4 hours, and then to home took 3.5 hours. And the distance was 1,900 for both. Both trips was the same distance, 1,900 nautical miles. Now, distance is equal to rate times time. So, my time, and then times the rate right here, is equal to the distance. Same thing with the flight home. My time times the rate is equal to the distance. Now we can figure out how to solve and try to find P and W. So I'm going to eliminate these fractions, or these problems here. Divide by 4 so that you can have P minus W by itself. 1,900 divided by 4, that should give me 475. Then if I take 3.5 and I divide 1,900 by 3.5, because I have to move the decimal also over one place, I'm going to add a 0 here as well. So then that's going to give me 509 for P. The rate of the airplane with no wind is approximately 509 nautical miles, or 509. And then the wind speed is approximately 34. The airplane's rate of speed is about 509 knots, and the wind speed is about 34 knots. Our homework for this lesson is posted right here. You'll do numbers 1 through 7 all, because those are grouped together. And it actually is not that scary. If you take a look at 6 and 7, they're giving you information, and all you have to do is just plug it in to the table that's given right there. And you have to define your variables based on the word problems here. Then, numbers 19 through 29 are word problems. You can set up a table, and also to help you organize your data. And I would set up the tables just like numbers 6 and 7, or 11 through 18. And then that will help you to determine your data and try to solve for your variables.